Welcome, ladies and gentlemen. So what I'd like to do is show you how to find the angle between two vectors. And basically, when finding the angle between two vectors, we have this nice, lovely formula, which cosine of theta is equal to the dot product of your two vectors, u dot v, divided by the magnitude of v and the magnitude of w. So it doesn't matter really what two vectors. They could be x and y and so forth. But in all my examples, I've labeled my vectors v and w. So we got to be careful with that. Or we have v and w. And then I went over the formulas for the dot product as well as the magnitude. So in reality, this really isn't too bad, but there's a couple things that I'm going to investigate that I'm going to kind of show you where you got to be careful. And we'll get to that here in just a second that we got to remember from our trigonometry days. But the main thing, and really to kind of visualize this, if I'll just sketch these two vectors here real quick. If I have this vector 2, negative 1. And then I have this vector 3, 4, 1, 2, 3, 1, 2, 3, 4. Basically, what we're looking into doing is trying to find the rotation between these two vectors, which we'll call theta. So that's basically what we're looking at, right? We want to find the angle between the two vectors. Okay, so you can see it's kind of pretty straightforward. You have this formula, you got to find the dot product, and then you got to find the magnitude. So the best thing that I tell all my students is, well, you should know how to find the dot product as well as the magnitude of your vectors. So let's go ahead and do all that information first. First thing I'll do is I'll write out the dot product. Now for the first one, I'll write it out kind of a little bit step by step. It's not a vector. And then I'll kind of move forward a little bit faster from there. I'm going to use parentheses not to distribute. So remember the formula of this. You can see here, this is my v1, v2. This is my w1, w2. So all I basically did is plug those values into my dot product formula. So I did v1 times w1 and v2 times w2. Remember, the dot product gives you a scalar. It does not give you a vector. 3 times 4 is going to be 12. 2 times 2 is 4. So therefore, I'm left with 16 as my dot product. Next thing I'm going to want to do is find the magnitude. Remember, the formula of magnitude doesn't matter what the name of the vector is, v, w, x, y, z. It's going to be basically your first component squared, which in my case is 3, and then add that to your second component squared. So in my case, I have 9 plus 4, which is 13. And then when I do the magnitude of w, I'm left with the square root 4 squared plus 2 squared. Well, 4 squared is 16, plus 2 squared is 4. 16 plus 4 is going to be 20. I'm going to simplify my radical. You don't have to, but I'm just in the habit of it. Simplify my radical. I can pull out the square root of 4, which is 2. That's going to leave me with the 5. Okay, since we're plugging everything into the calculator, you don't really need to simplify it. Actually, yeah, we're going to be using the calculator, so I'm not going to worry about simplifying. Okay, so we got our two magnitudes, and we got our dot product, right? Now, let's go to our formula. Cosine of theta is equal, because that theta is what we're looking for, the dot product, which is 16, over the magnitude, which is 13, square root of 13, times the square root of 20. And again, you could simplify that if you want to, but we don't have to. Now, the main thing that we want to understand, though, is we're trying to find theta, not cosine of theta. So I need to undo the cosine function. To do that, we're going to use the inverse cosine. So therefore, my theta is equal to cosine inverse of 16 divided by the square root of 13 times the square root of 20. And that's what I'm going to plug in my calculator. Now, for these problems in vectors, we're going to be looking for our angle in degrees. So I'm going to make sure my calculator is in degree mode. And I'm basically going to plug this in. Again, you could simplify it, but it's not necessary. So I'm going to do the second cosine, which gives me cosine inverse. And then I'm going to do 16 divided by the square root of 13 times the square root of 20. Close all my parentheses, and I get 7.125 degrees. 7.125 degrees. And if you were to look at these two angles, these angles are very, very similar to each other, right? 1, 2, 3, 1, 2, 4, 2. So you can see that having a small angle, and again, when you're doing this, it makes sense to kind of just sketch the angles just to make sure that your answer makes sense. Having 7.1225 degrees makes sense for this problem, right? It shouldn't be like 360 or 28 degree or 140 degrees. Small angle works. And that's going to become very, very important, especially when we get to a later problem, which I'll explain to you at that point of time. Okay, so now on the next one, I just want to kind of catch you off guard here and say, yes, this can be as easy as it looks. Rather than trying to always find the angles, just understand what you're trying to do rather than doing the math. And a lot of students won't even think about the problem. They'll start doing the magnitude, the dot product. Let's think about it. My vector v is 1, 0. My vector w is 0, 1. What is the angle between those two vectors? You're right, it's a 90-degree angle. So without any math, I'm just going to move to the next problem. So for the next problem, we have an angle that actually almost looks 90 degrees, right? It looks pretty close. So we know my answer. We're going to want to make sure we have an angle that is going to be roughly around like looking close to like that 90 degrees. We shouldn't have 250 degrees between these two angles. But then again, we're going to do the same operations. So I'm going to do my dot product. So I do v dot w. And again, these aren't in component form, but you can think of this as v1, v2, w1, w2. So my dot product will look like this, 2 times 3 plus -1 times 4. So that equals 6 plus -4, which equals 2. I'm going to erase this. Hopefully, you'll just kind of take a mental note. Actually, let's try to maybe leave that there. So let's find the magnitude of v equals the square root of 2 squared, which is 4, plus the square root of -1, which is 1. So that equals the square root of 5. Magnitude of w is equal to the square root of 3 squared, which is 9, plus 4 squared, which is 16. That equals the square root of 25, which equals 5. So now I'll do cosine of theta equals, I always like to write it out, even though I'm using the cosine inverse, I always just like to write it out so I just make sure that I have everything correctly. So it's the dot product, which is 2, over my two magnitudes, which is 5 times the square root of 5. Okay? So therefore, theta equals cosine inverse of 2 over 5 square root of 5. So then, again, we go back to our calculator. And I type in cosine inverse of 2 divided by 5 times the square root of 5. And my answer is 79.695. 79.695 degrees. And you can see, does that kind of look pretty similar to that? Yeah, like we're pretty good, right? Okay, so the last example, let's just kind of work our way through it here. Again, we're just following the same operations. But again, I don't want you to say, oh, okay, I got it. You know, these two examples are pretty straightforward. You just plug it, you just do your operation simplified. But there's a way that you're going to get messed up. And this is where students get mixed up. And I'm sorry I kind of waited to the end to go over this problem. So I hope nobody left. So first thing we want to do is find the dot product. So I do 3. Notice I don't have an I in this case. So that's going to be 0 plus 5 times -2. So therefore, I end up with a dot product of -10. Finding the magnitude of v is going to be the square root of 9 plus, square root of 3 squared, which is 9, plus 5 squared, which is 25. So that equals the square root of 34. Magnitude of w, I don't need to use the formula because there's only one component. So it's going to be the square root of 2 squared, which is 4. Well, actually, I already know. If you just sketch -2j, there's 1j, there's 2j. So we know the magnitude is just 2, right? OK, so we plug this in our calculator. Cosine inverse of -10 divided by 2 square root of 34. And again, you could simplify if you like to, but since we're plugging into the calculator, it doesn't really matter. So I type in cosine inverse of -10 divided by 2 times the square root of 34. And I get 149 degrees. And majority of students will say, OK, boom, got it, 149 degrees. But we have to think about, again, let's sketch what these two angles look like. Here is negative 2j, right? This other angle, 1, 2, 3, 1, 2, 3, 4, 5, is over here. Does the rotation of these two angles look like it's going to be 149 degrees? Well, no, it doesn't look like 149 degrees, to me. And the reason why that doesn't, the reason why that's not coming into play, I guess you could look at it going to there. Actually, let me look at that. Because if you do that, let me see what that other angle is. Plus 2, 149, 50. Yeah, OK. So I guess, OK. So yeah, that works, actually, because then you could look at that rotation between those two. OK, good. Never mind. That will work. So that equals 149 degrees. What I was looking at originally, which kind of caught me off guard, is this angle. You notice that these are greater than 180. Well, the inverse cosine, the range of inverse cosine is between 0 and pi. So therefore, the 140, what it's actually giving me is 149 degrees. So it's giving me the angle that's within its domain. But if you look, so it's giving you that angle. But if you subtract that from 360, you get 210, which would be that red angle. But I guess that, that can work either way as far as the rotation, because I guess you don't have to go. Well, I guess if you are saying from V to W, what is the rotation of those two? Yeah, I guess you could go in that negative direction. But if you're thinking of positive directions, I guess I should be clear. That is 149 degrees. That's negative 149 degrees. So you're right. So I was right. So again, the inverse cosine, remember the domain is from 0 to 180, right? So when I typed in this angle, the inverse gave me 149 degrees, point approximately. But that's not the angle in the positive direction. So what I have to do is subtract that to find the angle in the positive direction. So what I did is 360 minus 149.036. And what I did when I got that is 210 degrees, 0.96, which is going to be the angle in the positive direction. So if they're looking for any angle in the negative direction, then the 149 would work. But since we're looking for in the positive direction, or at least that's what I'm going to say now, it's going to be 210 degrees. So very, very careful, something that comes up. So we did it in the last example when finding the direction of an angle for tangent that came up. So just something you want to be aware of. Thanks. All right.